This is on page 625. Okay, again, it doesn't say prove. It says solve. And it's frozen. It's really frozen. All right. I'll just underline the word solve instead of trying to highlight it. So we want to solve, so we're allowed to work on both sides of the equation. Problem in this one is we have cos x and sine squared. So similar to the last two examples where you have two different trig functions. Can we use an identity? Yes. What could I write instead of sine squared? One minus cos squared. And now my function only has cos. If I distribute this -2, I'm going to get a positive 2 cos squared x, still have -3 cos x, and I'm going to get 3 minus 2, which is plus 1, equals 0. Let's see if we can factor this. Maybe we have to use the quadratic formula. If you could factor it, it would have to be 2 cos x and cos x, and 1 would have to be 1 and 1. We have to check, can our outside and inside combine to get a -3? Yes, if they're both negative. So now we can split it. Either cos x equals positive 1/2 or cos x equals 1. When is cos x 1/2? Pi over 3 family, quadrant 1 and quadrant 4. When is cos x equal to 1? The axis family, in particular, at 0 and 2 pi, right? So like always, again, I was doing this before. These are our solutions between 0 and 2 pi. But at this moment, I should reread the question to make sure it was in radians and not degrees, and to make sure that the domain was right. What domain did they want? It is in radians, so at least that's good. But it's only from 0 to 3 pi over 2. That's only quadrants 1, 2, and 3. And 0 is included, but 3 pi over 2 is not. Can you see that you would have to get rid of this answer? Because that one was in quadrant 4. And you would have to get rid of 2 pi. And our answers are only 0 and pi over 3. And question number 10 for practice on this one as well.